apart from TML, I'm also one of the employees at Telram, which is the office in front of this building. We have two speakers today, but before introducing them, just a brief introduction to TML, Transport and Mobility Leuven. Maybe most of you know that we are a spin-off. We exist already for more than 20 years. About 1.5 years, we had a big party over here with a lot of people. It was fun, and that was not only the party because of our birthday, but also because of the fact that we have a new office. So this is our new office, and we also have a small conference room. A lot of colleagues working on transport economics, impact assessment, costs and benefits analysis, but also a group of people working on traffic flow modeling. We also have our own product, which is Traffic Scouts. Apart from the traffic counter, Telram, there's also a low threshold traffic model, which is a Traffic Scout. And working on different fields, multi-model approach, not only in the air or in the ocean, but also rail and road, and both for passenger and freight transport. The red line in all those projects and research projects is mostly it's dealing with numbers. It's strongly qualitative, but also and mostly quantitative, and always in support towards a local, national, or even European policy framework. So we're working for municipalities, cities, the European Commission, and different regions, but also sometimes for a federation, for example, of road transport employers. So that's a brief introduction. Some guidelines, some practical guidelines as well. If you have a question for one of the two speakers, you can ask your question right behind the presentation. If it's a short question, maybe something you couldn't understand very well, but I would like to have the Q&A after the two presentations. And my colleague Jan at the back of the conference room, he's recording the TML Talk. You can find the TML Talk afterwards on our YouTube channel. We already have a few of those TML Talks over there recorded. Not all, but most of the TML Talks are there. And if you would have a suggestion for a next talk, we are going to have a next talk in Dutch at the beginning of October. But if you would have a good idea, never hesitate to send us an email. We're also active on social media, so if you don't want to share your question here, you can always share it online, but use the hashtag TML Talks. And that brings me to the topic of today. We invited two speakers to talk about carbon pricing, and the first speaker is a colleague, is Professor Stef Proost, emeritus professor, but still active and an eminence in the field of transport economy. And he brought us today a student, a PhD student from Sweden. But first, I would like you to give the floor, Stef, to explain us a little bit more of what you would like to say on air transport and carbon pricing. The floor is yours. I will give you this, and I will put your presentation.
Thank you very much. It's always a pleasure to be here with colleagues and some of my former students, etc., etc. So I like this place. Okay. Now this is one of my favorite topics. I started to work a little bit on this, I think maybe 10 years ago, together with Inge, where we were asked by the European Commission to discuss what is called sustainable aviation fuels. So the future of, and they wanted absolutely to have a very strict requirement, a very strict blending requirement for fuels. Inge and I in a bigger consortium, we studied seriously, and our advice was, it's a very costly way to do it. So maybe do something else. And that was a start, so I started to look at international emissions. And I've been working a little bit, but that's more than 30 years ago, also on international agreements. And it's one of the tough topics when we look at climate. What I will do, we'll discuss a little bit aviation, and then I give the floor to Saana. Okay. A few things we need to know. First thing is that the Paris Agreement, you say the Paris Agreement, I think 180 countries signed it, so we are in safe hands. They made really strict commitments. They say we're all going to reduce emissions, and some countries like the EU said we promise to go to net zero in 2050. Now, what we don't know, or what I didn't know beforehand, is that the Paris Agreement covers what the emissions that are related to what happens in a given country. But if you fly to another country, or if you transport goods to another country, that's not strictly included, that's not covered by the Paris Agreement. So we need other agreements to do that. That's one of the topics, okay? We need specific commitments for aviation and for shipping. For aviation, it is the CORSIA agreement, and that's something I will discuss today. For shipping, one is still preparing a specific agreement. Okay, but that will be discussed by Saana. Now, international agreement is very nice idea, and we have a lot of politicians that are ready to see me signing the big agreement with a very big signature. Okay, that's what you see. But we should not forget, climate is a very specific problem. It's what we call a cumulative public bad. Most of you know that. Whenever 1 ton emitted now will be active, will just accumulate in the atmosphere, will be active for the next 100, 200, 300 years. So there's a small decay factor, but will be active for a long time. Now, the ideal solution is that all countries stick to their commitments. And we have seen very strict, very strong commitments in Paris in 2015. But one of the problems of these international agreements is that they cannot be enforced. And that will be a very important characteristic, a very important property of the things we're going to discuss today. If you say, yes, they signed it, so it's all done. We just follow the agreement. No. Unfortunately, it's in the interest of a lot of people that whether they sign or not sign, to say, yeah, we do our best. But in practice, they don't do a lot, because it's better that all the others make an effort and I don't have to do anything. Or I'm pretending I do a lot, but I don't do a lot. So it's typically what we call a prisoner's dilemma. So at best, we can count on small efforts. We need to count on a lot of green pressure to get things moving. Nothing will happen, okay? And I call it very much a stop and go process. Look at the US. In the US, what we will see is that Biden is more active. So the present government, or the present president is more active. But imagine that we have Trump. A lot of things will happen. But one of the things he will say, yeah, no, climate, yeah, no. It's important, but okay. Okay, so we have stop and go policies. And it could be that in the EU, we have a little bit more of that too. And not only in the EU, in many countries. So you see this prisoner dilemma. It's very good that the others do something. We sign, we're a very goodwill, but it's not enough. Okay. So this is kind of summary of what we risk to see is that, okay, climate change is real, and we have these agreements and the follow-up of the agreements. They're all fine. But in reality, we may see different things. Okay. What I'm going to do today is discuss bilateral aviation. So CORSIA actually limits the emissions for if you have two countries signing this agreement, they promise to limit or to stabilize, or do a little bit better, stabilize emissions for the next 10, 15 years, emissions for aviation. Okay. If the US and Europe sign the agreement, they both promise that for all the flights between both of them, they will limit the emissions, they will stabilize the emissions. Okay. Now I will do that for aviation. Saana will discuss similar type of agreement that does not yet exist for maritime. Okay. What I'm going to tell here, I don't know whether Saskia is listening to me in Scotland, but this is some joint work with Saskia. Okay. Saskia van der Loo. Okay. Aviation, we have to make a difference between aviation within the EU and aviation between different continents. Aviation within the EU, that's pretty well regulated, is regulated by emission permits. Whenever you want to fly within Europe, you have to be able to show I bought a permit. And the permit compensates for the emissions of the flight. It's something you can perfectly do. It's something you can control. It's very well known. There's a few problems in the sense that 1 ton of fuel used in the air is not exactly, has a little bit more, generates more climate damage than a ton of fuel used. Okay. Now, there they now also introduced the sustainable aviation fuels that we found that it was not really very good idea. But okay, these things exist. And if you understand this very well, it means that replacing a flight by a rail journey does not really do a lot about, it's not really an important action if you want to reduce CO2 emissions, because there is some kind of, both of them are part of the same compensation mechanism. I'm not going to explain this, but it's really worthwhile to think about it. Now, international emissions are limited by an extra international agreement, CORSIA. So any two signatories promise to stabilize emissions on their flights at the level of 2019 minus 15%. It's signed by, I don't know, it varies, 115, 120 countries, but it cannot be enforced. The question is, will it work? Okay, this gives you an idea about the number of passengers from departure to a given destination. If you look at Western Europe, so this is actually inside Europe, okay? So this is covered already by the Paris Agreement, by the actions of the EU. All the rest is not covered by anything, okay? So the same for the US. In the US, for North America, I say most of it will be the US, you have also Mexico, but here, this is inside the US. There's small actions, there's some subsidies for fuels, things like that, but there is not that much. But this is in principle also covered by Paris, and here, Far East Asia, again, is a large part, which in principle is covered by Paris, but there is not that much happening. So what we are dealing with is exactly this part flying outside the continent, okay? And for some countries, it's pretty important, okay? Now, what CORSIA actually does, CORSIA is actually set up, ICAO, it's just International Civil Aviation Organization, okay, it's actually the airlines, put it this way, okay? They said there was so much pressure to do something about aviation. I think, yeah, there was a public pressure, so let's do something. Here you see the net CO2 emissions, okay? They're expected to grow. So everybody expects aviation the volume to grow, okay? And also including the emissions. So they said, okay, we're going to stabilize to 2019 level, minus 15%. And how will it be done? It will be done by these bilateral agreements. Everybody who signs accepts to stabilize emissions or do slightly better. And they're going to do this by better fuels and better aircraft technology. That was the initial plan. We will have a look at that. And of course, if you say, I want countries to promise to do something, you also want to know a little bit how will it be done. And what is accepted, okay, is if you of course fly much less, then it's clear, you have less emissions. But most of these countries just want to continue to fly. And how they will stabilize is in two ways. First of all, by something called offsets. Offsets means that there's a compensation in other sectors of the economy. If within Europe you have to buy permits, these permits means that another emitter in Europe will make extra efforts. So offset is something similar, but it's not defined because ETS is for Europe. The other method that can be used is these extra cleaner fuels. Okay. Now, before you go on and say, okay, this will work, you have to think about what does it really mean? Will it work, these offsets? And with these offsets is not yet well specified. You can buy offsets for less than €5 per ton. The price of permits in the EU is 60 to €100. So something looks like this is too cheap to be true. It's too nice to be true. So it's probably not nice. Okay. So these offsets have to be additional on top of what you do for Paris. But if you make strong commitments for Paris, it's very difficult to find cheap offsets because you do already a lot of efforts in many sectors. So it's not so obvious to do it, okay? Europe puts an example. They have this type of offsets. They can use ETS, so there it will work. So offsets, you have to be a little bit careful. You cannot accept offsets for 5 or 10 euro per ton of CO2. The same problem exists for sustainable aviation fuels. So you feel in the end that the CORSIA agreement has been made up. It was a success for the international aviation organizations, but in the end you feel it's not that serious. That will also again be my conclusion. So SAFs, they exist, they cost maybe 2 times, 3 times more for the biofuels. The biofuels is all kind of fuels made out of biological material. They are cheaper because they have already part of the process of making hydrocarbons is already in the bioproduct. Okay. The better fuels are e-fuels. You do it by combining hydrogen and carbon, but hydrogen is also expensive, and the carbon you have to extract it somewhere. So you have to capture the carbon, and that as such is also expensive. So they come with a much higher price. They may be better. Okay. The second problem is these SAFs. They have important indirect emissions. What CORSIA accepts, they accept from the moment the indirect emissions are less than 90%, they're accepted. So you say, yeah, no, you can see it in the agreement. So I think it's not very serious. Huh? It means that you say, I compensate something, but it's only compensated up to a level of 10%. Yeah, if you count that for 100%, it's not serious. Okay, so there's a problem there. I say this means anything goes. And of course, many countries will sign under these conditions. But it's not really effective, okay? On SAFs, I think there's some work you can consult. Are you asking more information? So there's a paper by Inge, Eve, and many other people. Okay. There are a few more complications. What are the complications in aviation? First thing is that whenever you use fuel, a ton of fuel in the air, it generates other greenhouse gases than just CO2. It's a complex process, but anyway, the result is that if you have the same ton of fuel used up in the air and the same ton, if you compare it with a ton of fuel used at ground level, then you have to count an extra 70%, an extra, that's a kind of multiplier. Some people say it's more like 3, some people say it's a little bit less than 1.7. So it depends a little bit on what's happening exactly, what is the flight that you do, etc. But we use 1.7 and maybe 1.4 for biofuels. We still keep into account that there are indirect emissions. So even for e-fuels, you have these 10% extra emissions. And you have to be careful, because if you really want to work only with biofuels and you want to compensate a ton of emissions, a ton of kerosene, and you do it with biofuels, you have to be careful, because on the one hand, 1 ton of biofuels has indirect emissions. On the other hand, just if you want to compare it with 1 ton of fuel that you do not use in the air and you substitute it by biofuels, it may be hard to just compensate, because you have these 2 factors that go against you. It goes, so you have the indirect emissions first, and secondly, you have this extra multiplier. Okay. Okay, our approach is, everything I do is very simple. Okay, now you start there with a problem, is that you have an agreement with a lot of doubts. We are not sure, first of all, we are not sure whether the country that signed will do something. That's number one. And secondly, they use SAFs, they use offsets. That may be not so serious either. So there's a problem on many sides. And so what we did is say, okay, we're going to consider that a country that really signs the agreement is a country that is serious about climate. And so we do only what is the real effect on climate. We try to compute it seriously. And secondly, we only take into account countries that will have a minimum willingness to pay to avoid climate damage. So we took it on the safe side, and maybe we are a little bit pessimistic, but at least we know that this looks like a real contribution to climate, okay? If I'm serious as a country about climate, I only do things that are serious. Of course, I can sign and I do other things, but that's nobody's interested in that. That's in French I say for the galerie, okay, whatever. How do we do it? Simple model. Imagine that we have, we fly to another country, okay, US to Europe, whatever. We have demand for aviation, demand for energy for aviation, okay. That will grow over time, and we try to see whether, for instance, in 2035, we can stabilize emissions or do slightly better. Now, how can we do better? By first making sure that we fly less. If we fly less, for instance, imagine that we reduce volume of flights from this initial point to this point, the effect here is actually what we save by just not using kerosene is the amount of kerosene, 1.7. Because we have these indirect emissions, not direct, but we have this multiplicator that we are avoiding. So that's important. I can also do it in another way using offsets. What we do with offsets is that we ask the airlines to buy offsets, to buy this compensation. And what will happen is that they will buy this compensation. We have to take into account it's real, so indirect emissions we have to deduct or to take into account the indirect emissions. And secondly, so what it will mean is that the airlines will charge more for their flights, okay? They will have to buy these permits, okay? But this will be the extra cost. But so that's the second mechanism we try to take into account. So final point, and that's an important point, is that there's some kind of advantage of bilateral cooperation whenever you fly to the US. Actually, if you fly to the US, the benefits of flying to the US are more or less divided between the US and us. That's clear because you're transporting passengers, you're Americans, Europeans, and you can also trade. We are getting the benefits of trade. And so this means that whenever you lose consumer surplus, whenever you have to give up some flights, the cost of that is shared between the two countries. So it's interesting that you only pay half of it. And that's the benefit of this bilateral cooperation. And, okay. So actually what is important is to consider the damage that one country wants to avoid and compare that with half of the price of the offset, half of the cost in terms of consumer surplus. Okay, and then of course, you wonder, what does it really mean? What will be the effect? And here we looked at 10 important blocks in the world. We looked at the bilateral trade between these different bilateral flights, whatever, the flights between different continents, Australia to China, China to Australia, whatever. And then we want to compare it, and we take an offset price, for instance, of 31 euro. It's clearly more than the 5 or the 10 euro, and we take into account, so this should be a serious compensation. Now we have to, this is the cost of using offsets. We have also to take into account what is the benefit for the country of avoiding climate damage. And whenever you want to do environmental economics, they know if you want to study a benefit of something, you can either look at the stated benefit, say you ask survey, you survey people, say how much is it worth to you, and people say something. Okay. The other way of approaching finding the benefit is what we call revealed preference. You say, I observe what you do, and from what you do, I see what you really want. What is your real value? That's revealed preference. And there is, from the OECD, there is our data about what are on average the tax or the permit price in different countries. What is the value of a ton of CO2? How much are you ready to take as measures to do something? For the EU is 28, US is much less, and you go down here. Japan is still serious, okay? You put that together, and then you try to see whether there are pairs of countries that want to make such an agreement. So to get an agreement, you have to make sure that both parties of the agreement, for them the cost is lower than one of these values. That's the story. So to illustrate, let's take a look at the EU. The EU, so what we take into account is actually half of the offset price, and we compare that with their value. So that's still okay. EU will say yes, okay? They will stabilize. Canada will also say yes, because for the case of Canada, it's also more or less half, let's say half of the 31 is smaller than the value and the 20. So there will be an agreement. EU and Canada will both sign the agreement and will do it seriously. That's the conclusion from this exercise. You will see in other circumstances there will not be that much, but what just in the end we found for the EU, the US, Japan, Canada would really join CORSIA. The others would not. They sign, but we don't expect that there will be a lot of action. Okay. Conclusions. CORSIA is a weak agreement. Okay. You can say it's always good to start with something. Okay, I agree. But if you say, okay, if we sign the agreement, we sit down. No, this is not okay. It's important to know how it is done. Take into account multiplicator of kerosene in aviation. Only if we count also, if we correct for the indirect emissions, okay? The nice thing about what we found in this, studying this agreement is that by the bilateral, you mean that whenever the emissions on these flights, the cost of it, the cost of reduction, is actually shared between the two countries. So that's a good thing to do. Now, there are a few more problems that we did not really consider. One of them is that we use perfect competition assumption. Here it gets a little bit technical, economics. So if you have duopoly or a monopoly, you know what is a monopoly? Is putting a high price in order to sell less. Okay, that's what you do. You restrict the demand and you sell at a much higher price. That's it. Now, if you have a monopoly or a duopoly, the prices are too high. And then, as an economist, you say, yeah, we gotta try to save some climate emissions, try to save some climate damage. What we're gonna do is add an extra tax, add extra requirement, add the SAF, add offsets. But this means that you still reduce more the quantity of flights. So that, as an economist, you say, if I look at the welfare loss and I compare the loss of consumer surplus, loss of passenger surplus, and the loss of profits for the airlines, with the saved, whatever, 30 euro per ton, that doesn't, the balance is not right. So the result would be that we would go to something like, and there are several papers that do this type of computation. They say what we should do is subsidize aviation to use cleaner fuels. Now, I have some problems with that because it kind of, you can always try to sell that to the politicians, say, yeah, no taxes on aviation in Belgium. Now we should subsidize aviation because the prices are already too high. So it's kind of difficult story. Certainly, this is our analysis just for one market, but of course there are many markets. If you look at the steel market and other markets, they're also in perfect competition. So on that end, you would say, yeah, if we really consider the whole economy, maybe we should also ask extra efforts from aviation. And then you can go on, you can make things much more difficult, network effects, carbon leakage. And this is the end of my story. Thank you for listening.
Thank you, Stef. Any short question for Stef? No? Okay.
Okay.
Saana, working together with Stef, and you're working at the Swedish National Road and Transport Research Institute in Stockholm.
Yes.
But originally you're from
Finland. Yeah. Indeed.
Okay, it's nice to see you.
Baltic Sea anyway.
Okay, we're really looking forward to your presentation.
Yeah.
We just had a critical, serious reflection on CORSIA, so we expect also some reflections towards
I'm sorry.
shipping. I will put your presentation and then...
This is number one.
Okay. Yeah. Like this? Yeah. Yeah. Can I put it in my pocket, maybe? Yeah. Okay, perfect. So yes, again, so my name is Saana Ollila and I'm happy to be here. And I said so, I'm a PhD student in Stockholm, working at VTI and affiliated to University of Linköping. And I'm going to present a paper which has a working title, Welfare Effects of Carbon Pricing in the Shipping Sector. And I'm working together with Stef and then my supervisor, Maria Börjesson. And the story a little behind of this paper is, as Stef told, so we don't have any agreement how we should reduce emissions from global shipping. But in this paper, we look at like one way to design that kind of policy, and then also what kind of welfare effects that kind of policy or policy design that we propose would have. a little bit of background. So IMO, International Maritime Organization, published 2023 an updated greenhouse gas strategy, where they defined that, okay, aligned with the Paris Agreement, so we want to reach near zero emissions by 2050. And then what they proposed there, so they proposed two different kind of medium-term policy measures. One is that there going to be, or there should be, some kind of limit for carbon intensity of fuels. And the second is that, okay, we also maybe need some kind of price on carbon emissions or market-based measure. And the reason for this is that, as we see in the picture, so emissions from the shipping sector are today approximately 1 billion ton. And if you don't do anything, so we are not anywhere close to reach zero emissions by 2050. It's estimated to grow a little depending on the scenario, up to 50% by 2050. And as discussed previously, so the problem when we try to agree on these kind of global emission reduction policies in the shipping is that countries are independent and they can decide whether they want to commit to the agreement or not. And it's very difficult to enforce countries to do that. And why we look at global shipping, so global shipping, if you look at like the total shipping sector also including domestic shipping, so global shipping accounts something between 80 and 90% of total shipping. So that's why the most of the emissions are actually from the shipping between the countries instead of within the countries. So what we do in this paper, so we so far look at only carbon pricing or market-based measures. And in the presentation, we refer a lot of carbon taxes, but that could also be applied to tradable permits in a similar manner, giving some assumptions hold. But yeah, carbon pricing or taxes or tradable permits, the results should hold all of those. And the idea is similar to CORSIA, that we assume that countries can agree on bilateral carbon pricing or maybe in the future bilateral emission reduction policies, including possible, I don't know, limitations to fuel standard or something like that. And then we look at 4 scenarios. First, we start assuming full cooperation, assuming a little bit like idealistic world where all countries cooperate and agree on a common carbon price. And then we look at what would be the effects, how much emissions would be reduced. And then we also show that, well, some countries lose actually if we have a full cooperation, which explains that it's not like very realistic scenario in that sense. Then the second case is when we look at what would be if the countries would impose unilateral carbon pricing, giving some assumptions, what would be the welfare effects and also effects on emissions. And then third and fourth scenario, we look at the bilateral agreements, and we assume that countries agree on a common level of carbon pricing, and then we look at the effects in the scenario 3. So we assume that the tax revenues or tradable permits are equally divided between countries, and in the case 4, we assume that countries can agree also how they want to divide or tradable permits. A little bit of the model assumptions. So as said, so it's countries that decide the carbon pricing or the carbon policy pricing, and then it's shipping companies that decide how to abate emissions. We assume that emission reductions can be reduced, or emissions can be reduced to reduction in trade, so that we just ship less, or we can implement abatement technologies. And as we saw in the last presentations, so the countries have different damage costs and therefore also different preferences for carbon pricing, which is part of the reason that it's difficult to agree on common policies because each country has a little different idea what would be optimal. And through the paper or study, we assume that there's perfect competition. Shortly about model. So it's a very simple model. We assume it doesn't look like that, but it is. So we assume that we have quadrilateral trade benefits. And here it's also important to note that we assume that if EU ships something from China and the price increases, so EU cannot ship the same products from some other country. So we don't account this kind of substitution in trade between countries. Then we have our transport cost, which have 3 parts. One is just constant. Then we have how much it costs to abate emissions. And then we have what is the cost of the policy for a shipping company, or how much the carbon pricing costs for the shipping company. And then what we find is that the abatement level is actually defined by the ratio of carbon pricing with respect to how much an additional unit of abatement cost. And this is our workhorse. Well, so we have trade benefits, then we have trade cost, what is the cost of emissions for the country, and then we have the climate policy or tax revenues. This is the price element, and then the red delta denotes how the tax revenues or tradable permits are divided between the countries. A little bit of data. 2 interesting points are the abatement cost function and climate damage cost. We construct own abatement cost function that we use in the model, and we take alternative fuels from a study by previously estimated Lago-Vardou, and then other technologies from this study. And as Stef told, so we also use the OECD's measure for implemented carbon pricing, which reflects countries' preferences, how much they are willing to pay if we reduce emissions. But then we also use, you cannot say more scientific, but something which is derived from integrated assessment model, which is like more nature science based, like how much each country will suffer if temperature increases. And the interesting point is that those differ quite significantly between countries, and it somehow reflects that when we have this kind of international negotiations, so countries can come there and show their own valuation, and then we try to find out that, okay, is it realistic or not? But each country can have own preferences, and depending on which kind of measure you use, so the results can vary quite significantly. And here we have our abatement cost function, which is a critical part of our paper, and it defines how much it costs to reduce emissions by one unit. What is here? In the right corner, we have more like operational measures. We have speed reduction, voyage optimization. Those are that kind of measures that can be implemented already today. You don't need to install anything for the vessel. Then we have LNG. Today we already have some LNG vessels. Then we have alternative fuels, and we see that they are much more expensive, but at the same time also the emission reduction potential is much higher. And all these values are including the approximated future cost of alternative fuels and the cost of buying a new vessel. What we can think about in this is that if you have some kind of technological development or price of electricity decreases, so we could see that the curve becomes flatter and it becomes cheaper at abate emissions. Then something which is like some, especially economists, may think it's a bit weird that we have negative abatement cost here. That's very typical for the shipping literature when they estimate things. They say, for example, that it could be like almost beneficial to use voyage optimization, but because of some market inefficiencies or contractual factors, it's very difficult to implement. Then the question is, should it be accounted in the cost that it's difficult to implement, that the cost should be positive, but that's the reasoning why you can see negative cost. And here again, illustrated a little bit of the difficulty that when we have international negotiations, so little depending on which source you use, so the climate damage varies significantly. SCC refers social cost of carbon, and I have used it quite in the same way than climate damage in this presentation. So we see that EU, when we look at the OECD's measure, EU, Canada value high carbon emissions, are willing to do much more, while US, Brazil, India are willing to do less. And it's kind of opposite when we use the social cost of carbon or climate damage cost derived from the integrated assessment model. Then the first case, full cooperation. So we assume that the tax or price of carbon emission is equal to the world damage cost of carbon emissions. And here we find the abatement level. And then the results look like this. So we see the blue denotes welfare change. The orange, it's change in trade benefits or net benefits. And the gray is social cost of reduction is in social cost of carbon emissions. And then we have the yellow, which is tax revenues. And we see that in both cases, the welfare, the global welfare increases. But most of the countries actually, in our example, face welfare loss. It's only the countries that have higher carbon or higher valuation for carbon emissions in panel A, where we use the OECD's valuation, which is EU in that case, that wins. And when we use the valuation derived from the integrated assessment model, so we see it's actually only the India that wins if we would implement this kind of uniform policy. And this illustrates exactly the thing that when some countries lose and some win, so it's very difficult to agree on uniform policies. And here a little bit, despite relatively high tax levels, so when we look at like the abatement level, so we see that it would maybe lead to more speed reduction, voyage optimization, maybe implementation of LNG, but definitely not high enough to introduce an uptake or intake of alternative fuels. And overall, we also see that it's like around 30% reduction in trade, while most of the emission reductions actually come from the reduced trade demand rather than implementation of abatement technologies. And that's due to the high abatement cost. Then the second example is, now we assume that, okay, countries impose unilateral policies, they do not cooperate. So as in the CORSIA and aviation, so we assume that the countries divide trade benefits and cost equally, but now they can tax all emissions. So for example, EU can tax all emissions from shipping from China to EU, and China can do the same. So if the ship sails from I to J, from EU to China, so it pays the tax that country I, EU, impose, and the tax that country J, China, impose. And what we find then when we do the optimization, so we find that in this kind of scenario, so each country would actually have a carbon pricing, which is a sum of the climate damage cost plus a markup. And this markup is very huge, and in the next slide when I show the tax level, so you see that maybe it's not very realistic scenario. Yeah. So here we have the tax revenues, and these are again the taxes, for example, between India and the US, following the valuation integrated assessment model valuation. So this is the tax the shipping company pays, so it's a sum of the tax posed by India and United States. So we see tax levels are much, much higher than the climate damage cost or valuation or preferences for carbon pricing derived from OECD, and that's mainly because of the markup term. However, these kind of policies would actually quite high emission reductions and high abatement levels, and potentially also intake of alternative fuels. But as we see, so the markup is not very realistic, and it's likely to violate the WTO's rule for free trade. And we see that most of the countries actually lose in this kind of pricing, which also explains that when the country knows that, okay, if I implement this kind of pricing, so also some other country will do that, and then we both lose. So it's like in that kind of balance. Funny though, it's that we see that actually those countries who have like high valuations for carbon emissions, so they actually may benefit policies like this. And so far we don't see many unilateral policies except EU ETS and the Fuel EU Maritime, which will be implemented starting from 2025. And then we have two final cases where we look at now the bilateral agreements where the restriction is that all countries have positive welfare or at least don't have negative welfare. So here we have the self-enforcing constraints. A, in this case, denote agreement, not abatement, as previously. And it says that in case we have bilateral carbon pricing, so the country must have positive welfare. And this is the constraint we use in the optimization, ensuring that no one loses when we implement this kind of policy. And here we have our tax levels and abatement levels. So we see Brazil here have OECD's valuation almost near to zero. So we see also that the tax levels are zero because they just don't want to implement any kind of pricing. Others, the tax levels vary from around 20 up to 125, 130. And the corresponding abatement levels are something between, 3 and 13%. Not very high abatement levels, but still something. And then we have, again, how the welfare impacted. And here we see that all welfare are positive. That's our constraint. But something which is good to note, so first of all, the reduction in net benefits or trade benefits is much larger than the reduction in the climate damage cost. A little depending on how countries see collection of tax revenues and use of tax revenues, so that can be like debated whether it's problematic or not. But what also we find that if you compare to emission level in 2007, so this kind of policy between 5 countries would approximately reduce emissions by 1%. Most of this reduction is due to trade demand, but overall we find that if we would implement this kind of policy, so the trade would reduce overall between these 5 countries by 3 to 4%. So yeah, maybe it's not like so big reduction in trade demand, but still. And then the final case is previous case, but now the countries can decide on how to share the tax revenues or tradable permits. And the idea is that if one has very high valuation for carbon emission and one has low, so the country with high valuation can pay to the other country to agree on higher carbon pricing. And what we find here, so we see that the tax levels increase a little bit, not significantly. The same with the abatement levels. So if we only look at the tax levels and abatement levels, so it really doesn't make very big difference in that sense. And then here we have how the tax revenues are, or tradable permits allocated between countries. And they are, for many country pairs, they are quite close to 50%. So there's not like few countries where there's bigger difference what is optimal, but more or less equally. And then the results are here. No big difference, but now we see that most of the countries actually have, those who had zero welfare in the previous example or very low welfare increase, so get like a bit higher welfare increase. And one way to think about this would be that, okay, maybe if those countries are a little less willing to join the agreement if they just like the welfare remains same, but maybe if they get something, so that would like in real politics increase their willingness to join the agreement. And also we see that the by this kind of agreement we can reach a little higher emission reductions if you compare to level in 2007. And to conclude, so what we find, so we have this kind of bilateral carbon pricing, so we can actually reduce emissions from the shipping sector. But however, the emission reduction potential of this kind of agreement is kind of limited, and it's mainly due to the high abatement cost. And if we think like what we should do to reach near zero emissions by 2050, so we would need a carbon price around $1,000 per ton of CO2 emissions, which is, well, quite high. However, which is like good to take into account is that our model is static, and one could argue that like if we impose carbon pricing today, so it will lead to more innovations and more productions of alternative fuels and ships with alternative technologies that allow us to use alternative fuels, and that could maybe reduce the marginal abatement cost. But that's future research. So that's all I had to say today. Thank you.
Thank you very
Yep.
much, Saana. It was a bit out of my comfort zone topic, but
Yeah.
I could follow. So.
That's good.
But maybe some of you have a question for Saana or for Stef. Introduce yourself and give your question.
Thank you. My name is Tim Verhoeven. I'm from the port of Antwerp-Bruges. Your emissions, are they allocated to the goods coming from the different countries, or is it based on shipping itself? Because of course you know that shipping is not.
Yes. No, I mean, yes, it's, I mean, that's a good point. And we have been just discussing about it, that it's possible that, for example, if you transport something from China, so you make a stop somewhere and then do that. But also in the ETS, they have defined these like a buffered zones, where if it's like transshipment terminal, how they call them, so then it doesn't count as a stop. So there are like some that kind of ways that it can be reduced, but of course it cannot be like banned like fully, or I don't think there's like completely like a fully waterproof solution for that. But I think here maybe the idea is little, that if we design a policy that the welfare for both countries is a positive, so maybe they have a little higher incentives to also follow the rules. That would be, I'm sure if it's like wishful thinking, but yeah.
Yeah, it is Reo, I'm with EG Shipping, for the Federal Public Service.
Yeah.
I'm wondering, of course, we pricing is a good idea.
Yeah.
But we see a lot of other countries do not agree with carbon pricing. They only want the fuel standard. What to you would be the main reason for them to agree to going into a carbon pricing mechanism?
Oh, that's a good question. Well, I would say that they get revenues from the carbon pricing, and then they can use the revenues in the way they want, which can be kind of nice in some sense. So I would say that's, and it's also most likely more efficient. But as we see, so like kind of like big part of the fact that we have positive welfare in our analysis is that we get like a lot of tax revenues. And maybe not all countries maybe have like so good institutions that it's like they're not familiar to handle that kind of tax revenues, and then there can be like different opinions whether it's good or not. So I think that, I mean, it's a problem for sure for some countries. Maybe, yeah.
Can you
join
Yeah.
on this question. There are different aspects. What you can do is, of course, you can work with permits. Permits, they will rise the price of shipping, okay? And what you can do is grandfather the permits. And that's the way you get more acceptability of the different pollutants. That's the way we did it for industry in Europe. And I think by grandfathering permits, and you could reallocate permits a little bit more permits for those countries that are a little bit more reluctant, and that's also what we do. We give a little bit more permits to Poland. But if we make this, it goes this way. So that's one way of buying in the polluters. Now there's another aspect, and that's more dynamics. Of course, in the end, you want better technology. But is the better technology the best way to get better technology? Is that with high permit prices? Because high permit prices say we want the permit prices. They are an incentive for very different types of abatement. They are incentive to reduce the volume, to have more fuel-efficient shipping, also an incentive for different types of subs. So that's the second choice you have to make. And it's clear that why do a lot of countries prefer subs? Because subs, okay, we start with 2% or 5% or 10%, and you say, yeah, it goes up. It's a nice promise. And that's also what we do in aviation. Nobody sees real subs for 60% because it's an enormous quantity. You will not be able to come up with 60%. And I'm afraid it's a little bit the same story for shipping. The methanol, what we will have, or ammonia, whatever we will use, you need enormous quantities of hydrogen and capture CO2. Now, if you know capture CO2, it's possible, you know it exists, but we are a long way from there. So I think it's kind of, I think this permit stories, I think I would look at it favorably. And of course, maybe other shipping companies or other countries are fighting it. But there's an enormous lobby for subs, for whatever, LNG, hydrogen, whatever. You see it in the port of Antwerp, you see an enormous pressure. But we'll see where we will get. But I think in the end, with a permit policy, you can also achieve a lot. And inside, we try to do exactly the same thing for electricity. Electricity, you start by saying, yeah, it has to be 10% renewable, 10% renewable. And after a while, we switch to a permit system, and with the permit system, we saw immediately much larger progress. Why much larger progress? Because one of the main effects of this permit system was that there was an incentive to shift from coal to gas. And gas emits only per kilowatt hour, only emits 50% of coal. And so there's an enormous jump in efficiency of your climate policy using these permits rather than to say, yeah, we need 10% of renewables, things like that. Okay, this is my view. I'm getting your history.
Yeah, I was wondering, do you think that there's a risk to increase, for example, for shipping environment that transport or ships to some extent to aviation?
Yes and no. I think some light's good, maybe if they're like, I don't know, aviation is still like much more expensive, although it's faster. So I think there can be like, I don't know, like expensive manufactured goods where like this substitution could happen. But in a larger extent, I don't think so. There are still like many like metals and like heavy products that are shipped, and those, I mean, it's difficult to move them by plane. So I think, I mean, part of the emission reduction for sure there can be like some kind of substitution, but I don't think it's. I don't think it will like impact significantly the results.
think what maybe not expressed very clearly is that whenever you go for climate policy, you should go for a cost-efficient policy. And so the fact that in the end we should absolutely do something in aviation should go to zero in 2050, I do not agree. Why not? Because it could very well be that you can compensate the emissions of aviation if you can do it in a cheap way by carbon capture, and of course, which is anyway the option you will need if you want to go for e-fuel. Okay, this for me is fine, because in net terms, it's zero. So we should be very careful in pushing for one policy. What I agree with you is that, of course, if you sign agreements, please, be serious. No, it's kind of, okay, there's no miracle. If you see that person, maybe countries sign, I'll say, you'll do it, and it's hard to do it.
The decision maker often wants to have nice messages with no or no impact.
That's your specialty.
No, he would like impact, but impact that hurts. That's nothing, or nobody, or doesn't hurt the actual power groups, let's say.
But
To some extent in any case, because that's the power groups are the heaviest lobby groups. They have money, they have power, they have incentives.
I know. So airlines are very heavy power groups, and ports are also very so lobbies. Okay, Android is here. So. You know what I mean. We need. I have nothing against lobbies. Nothing against lobbies. Lobbies can come up with very smart policies in their own interest, but also in the interest of the whole, let's say, of the whole community. That's fine, but maybe we should be prudent and maybe go for policies that really work and not announce that everything will be done and we'll go to zero in 2050, whatever, everything is possible, it's easy. I think we see it a little bit in the automobile industry, the same story. We have to be careful in what we promise, how much it will cost, and it's easy to say the new technologies are there. Yeah, they're coming and we should push them. But on the other hand, we have to be careful. I think, it's a difficult, I'm not a politician, so, it's difficult. I agree.
Maybe just to add, nice message, low impact. This was a message from the head of World Trade Organization yesterday in Financial Times. What do you think about the global carbon price?
The global carbon price, does it mean that we should have a price for...
Aligning all the different schemes now.
Yes.
Because she's talking about 78 different carbon price and indexation mechanisms.
But that's what our OECD measures, varying between 28 until whatever, 1 or 2 for some other countries. If all these countries agree to join a common system, it's very nice. And we can, once you have a common system, it's clear that there is an incentive to go for the cheapest solutions first. It could be that the cheapest solutions are not in Belgium, are not in the EU, but are somewhere else. So that as such, I agree. But I don't see these things happening, but okay, it's
a nice message.
It's a nice message, and again, then the same message probably what they do is they say now the total revenue should be distributed equally all over the country. Okay, that's again a more difficult story.
More difficult. So thank you very much. If there are no other questions, of course, we'll stay a little bit more here. We still have some sandwiches leftovers from the lunch. I would like to thank the speakers. We have a little present for you. show it to the participants. It doesn't have to do anything with shipping or aviation, but it has to do something with transport. And in the meantime, while they're opening their present, I would like to finish our talk with the introduction of the next talk. It will be in Dutch. Bruno is one of the speakers in this next talk. We're going to talk about the impact on air quality of local traffic measures. For example, if you have speed reduction, what is the impact on air quality? And they will come up with some good results from a recent study and project research. So you can show your book to the crowd. This is also kind of a critical, serious reflection towards traffic engineering. So we hope you like it and. Okay, thank you very much.